Hello everyone. In continuation of last lecture, uh, topic physical properties of mineral. So we have discussed already minerals and rocks, and about the mineral and rock forming mineral and ore forming mineral, and some properties, physical properties of mineral like color, streak, luster, form, and cleavage. We have already discussed. Now we are going to discuss remaining properties like fracture, hardness, specific gravity, diaphanity, and last one is identified minerals name. No, now I think you already know that color, natural color, which type of color is whatever the color, natural color is occurred in the mineral, that is its own natural color, and we will notified that mineral by these colors. Okay, and you already know that streak. What is a streak? Streak is a color of a mineral powder is known as a streak, and best example is hematite. Then we have discussed different type of lusters for in last class and with their example, and we have already discussed forms. These are the different forms: crystalline, amorphous, and these are the some example of different type of forms. We have already discussed cleavage. Now we will discuss fracture. Fracture, what is exactly fracture? Fracture is a mineral may be defined as an appearance of its broken surface. So when mineral is hammered and broken. Okay, when mineral is hammered, it will split into which form, that is known as a fracture, or feel of a broken surface is also known as a fracture. So they are categorized under the 4 category. First is even fracture, when the rock split with smooth surfaces, then it is known as even fracture. And feldspar is a good example of even fracture. Then uneven fracture means, uneven means when the mineral broke in the with uneven or rough surface, then it is known as uneven fracture. Conchoidal fracture, conchoidal fracture, this is example you can see here. This is these are the lines in this area. Even fracture means smooth surface. Uneven means when zigzag or the rough surface is formed when the mineral is split along the surface. Conchoidal means when concentric rings are formed on the surface. Whenever you see a glass, the edges of glass is having some concentric fractures. You might have seen number of time the glass is always give conchoidal fracture, and Hackley fracture is only given by the native type of mineral. Jagged, spiky jagged surfaces is the example of Hackley fracture, and cupride always give the Hackley fracture. Now hardness. Hardness is very important property for a mineral. It is most useful diagnostic property. It is defined as resistance of a mineral for abrasion or scratching. When we scratch the mineral, so on the basis of scratching, we can determine the hardness of mineral. And here Mohs scale of hardness scale is given on your picture. So Mohs scale, according to Mohs, he categorized the some minerals on the scale of 1 to 10. So talc, when talc is a softest mineral, you can scratch by your nail. Okay, So when you scratch by nail a talc, so definitely if the mineral is scratched by nail, so definitely it will be talc. Then second one is gypsum. So scarcely, gypsum is scarcely scratched by nail. So up to 1 to 2, they will scratch by nail. Then on the third rank, calcite will be there, and it will not scratched by nail, it will scratched by copper coin. Okay. And when fluoride having 4 hardness, fluoride and apatite, so they all are scratched by knife point or the glass plate. And number 6 is having feldspar. Feldspar is having hardness 6 and not scratched by glass or knife. They are scratched by steel. And afterward, after 7, 8 and 9, after 7, they are not scratched by any mineral or any metal or any glass piece. So after 7, quartz, topaz and corundum and diamond, these all are always find out relatively. When we scratch quartz by topaz, so quartz will be scratched. When corundum will scratched by topaz, so it will scratched. So by the physical verification, you can find out these hardness. Okay, so this is hardness scale, in which first talc, gypsum, calcite, fluoride, apatite, feldspar, quartz, topaz, corundum and diamond. This is the Mohs scale, and it is worldwide accepted scale. Now specific gravity. Specific gravity is a mineral, the ratio of weight to the weight of equal volume of water. Okay, so in case of physical property, when you are in field, you don't have any equipment. There is a equipment like Walker steel yard. By the Walker steel yard, you can determine the specific gravity of a mineral. But in field, you don't have any equipment or a laboratory. So by its weight, you can identify that if it is heavy, then its specific gravity is high. So it depends upon the intermolecular space and the toughness of the mineral. When it is too much heavy, so its intermolecular space is not available and it is very hard and compact. So it's if the rock is if the mineral is having high hardness, so it will always have high specific gravity as well. So it is categorized into 3 part: low, medium and high. Definity is equality or a state of being, deafness, especially ability of mineral to transmit the light. Okay, compare with transparent, semi-transparent, translucent and opaque. Okay, so just compare this. It is a transparent, it is transparent or semi-transparent, translucent, that it is totally opaque. No light can be penetrated through this, its body. So these all are the properties by which you can recognize the mineral in the field. So on the basis of these properties, you can identify the mineral in the field. So what we have learned in this lecture, we have defined so many properties of physical properties of minerals, like color, luster, cleavage, fracture and hardness and definity. So I think this much is enough for today, and if you have any doubt, then contact to me on my email ID bhargava.shubha@gmail.com. Thank you.